Hey everyone. Okay, so here we are. We're back again with HFM Tech School episode number 4. And we are here today, of course, with Lindsay Brackett, co-host, maybe
Hey,
prime host, and Tim Zacharias, who is president of Cougar USA and an amazing podcast host of Building Value. Welcome, Tim. Hey, tell us a little bit about you.
Thanks, Josh, Lindsay. I appreciate the invitation and the shout out for Building Value. That's been a fun project over the last couple of years. So glad y'all are enjoying that. So so I've started with Cougar back in 2007 and kind of started in more of like a project manager, financial kind of a role. I was a finance major from A&M, and from there kind of slowly worked my way through the operations of the business. Learning all of our equipment and our systems, both the products themselves and our internal businesses. And then, the last couple of years worked through the COO role and into president where I'm at today. So the company was started in 2003 by my dad, Mike, and his now also my business partner, Scott McGee. And so, U of H grad and my dad, that's where the Cougar kind of namesake comes from a little bit there. But Scott and I are Aggies, so we kind of joke that Cougar is gonna slowly darken to maroon over time, right?
Nice.
Yeah.
Awesome.
So and Cougar is sorry, go ahead.
No, you go for it. Go.
So Cougar, we're both a manufacturer's rep firm as well as a manufacturer of what we call water control systems. So we focus on pressure, temperature, flow, level and quality of water in hospitals, hotels, high-rise office buildings, institutions. We get to do stadiums a little bit too, so that's fun. But basically combinations of pumps, valves, and controls to do any of those applications in a commercial building.
Awesome. Very cool.
Very cool. Yeah.
Why you're here today. Because
Yes.
3, we talked about water management plans. And this goes in really nicely into episode 4, which is secondary chill water loops. And we specifically chose this, because it's kind of like they're forgotten about, not the primary focus, right? So, and it was your idea to, hey, why don't we talk about this? Here's a great idea. So what is a secondary chill water loop?
Sure. So, in a lot of these larger facilities, especially hospitals, you're using central plants for chill water to cool the building, comfort cooling in the building. But you can also kind of take that primary loop, peel off a smaller secondary loop with some control valves, heat exchangers, and other controls, and be able to use that as more of a process for cooling equipment. A lot of times in hospitals, that's going to be, or healthcare facilities, might be an MRI or some lab equipment or research equipment, things like that, so that you're able to cool it and allow it to operate without overheating. The MRI is the big example there. I feel like a lot of people know what can happen with that MRI if it doesn't have that constant cooling and the impact that would have to the machine and to the operation of the hospital. So unfortunately, the MRI gets a lot of the attention, but behind that, is it copper or whatever that wall is that protecting from the magnet on the other side, there's a cooling system that's helping it run, and that's kind of what we're want to talk about today is what's keeping that MRI running literally behind the scenes.
Wow. So it's so funny that you bring that up. I have a story on that. We have a hospital that 20 years ago had a 600-ton chiller installed. It was an expansion for the hospital, but right now we're in the process of, we run that 600-ton chiller in the middle of winter to supply a 3-ton load for our MRI. And it's one of those, we did some quick calcs a couple months ago, and we're like, wow, that is a really fast payback if we install a heating frame and do free cooling. So
sure.
I think that's something that is overlooked in general. Like we as an engineer, I can say this, and as an operations guy, I can say this. There's not often communication that goes into the design and construction side and the transition to operations and maintenance. It sounds like it's kind of where you dive in.
Yeah, so we deal a lot with the new construction side of the process and the design with the engineers. And then we also, about half of our activity comes from what we call the aftermarket or the existing buildings. And so we see kind of the struggles on both sides, what it takes on the front end to do the design, and then what you can be, I don't want to say left with, but what the struggles can be if the system that gets installed doesn't necessarily have what you would want as every day as an operator. And so we're trying to kind of work on both sides there to make sure that we're covering the controls and make sure that the actual piece of equipment is getting the cooling that it needs. And then you're also able to kind of address some of the redundancies so that you don't have a single point of failure that's going to take down that piece of equipment. So if you are going to do what you're doing right now, which is use that primary chilling loop, that primary cooling loop, and then go to the secondary loop and to be able to use that to actually cool the piece of equipment, you're going to want to have multiple control valves, a heat exchanger or multiple heat exchangers, and then secondary pumps kind of at a minimum. So your heat exchanger is what is kind of decoupling that primary and secondary loop between the two, but allows you to get the heat transfer between the primary and the secondary loop. Okay. And that control valve is on the primary side. You're modulating that based on the outlet temperature in the secondary side. So that's how you can maintain that constant temperature in the secondary loop. And then you're going to be needing to control those pumps on differential pressure to make sure that you're giving the proper flow to the MRI of the other piece of equipment. So a lot of pieces working together to be able to get you the right flow and temperature to the piece of equipment. And if the responsibility ends up on, say, the controls contractor and says, hey, here's all this pieces of equipment, you need to make this work. That's a lot of programming and testing out in the field to make a system like that work. So we found centralized controller specifically for that application can help address some of that coordination that needs to happen between trades, making sure that you're covering all the controls bases, things like that, and then communicating back to the building automation to give the temperatures, to give the alarms, all of those sort of things. So, having the multiple pieces of equipment, both at the control valve, the heat exchanger, and on the secondary side with the pumps, it's going to give you multiple layers of redundancy, in that transition. So
it sounds like there's a lot of coordination required on the control side, as well as just awareness as an owner, what is important to look for whenever you're looking at drawings from your design engineers and when to speak up. I know design engineers often push for two-way valves over three-way valves. Can you talk to us about what you would recommend for the setup?
So are we talking, so if we're talking two-way and three-way control valves,
yes.
On the primary side, that is going to be probably dependent on how the rest of the loop is set up. I'm I would say more of a fan of the two-way valves than the three-way valves in that configuration. Yeah. There's another application where we have the option between two and three-way valves that I want to talk about in a minute, but they're not control valves. So I think it's a little bit different conversation. But okay. So Josh, you have a preference two-way or three-way valves on the control valves?
On the control valves, two-way, hands down.
Yes.
Yeah. Especially like on the energy side, So, Lindsay and I really, we're ASHE faculty for the Energy to Care program. Woo-hoo, go ASHE faculty. And that's a big shout out to Kara Brooks right there. She's the manager for ASHE and our fearless leader. But two-way control valves for sure.
Yep. Yeah. So we typically do a two-way control valve on the primary side, but if the loop is set up for three-way, then it would, you could use a three-way if that was how you were wanting to configure it. So, that you'd have those three kind of pieces of equipment. You may have an additional kind of filter or something else in the loop, in the secondary loop that you might want to monitor differential pressure. So another device that might be tied into the controls. That's all if you're going to be kind of feeding it from that primary chiller, right? If you're going to do what Josh is talking about, might be a slightly different configuration where you're doing either the free cooling or putting in a dedicated chiller, then you're kind of making it more of its own little primary system. Still going to need to have some of the pump controls and the temperature controls to make sure that you're satisfying the the differential pressure and temperature to that piece of equipment, but you may not have, as much, might not have the control valves or things like that, depending on what your setup is. So with any of those, you're still dependent on a chiller at some level or some sort of pumps or things like that to be able to generate or transfer generate and transfer the chilled water. So if you do have a situation where any of those pieces fail, and we like to, especially from that kind of operation side, it's more of an if, not a when. You're going to have issues with mechanical and electrical equipment. So being able to build in an additional layer of backup can kind of keep you up and going when that worst case scenario happens. So this would be another application where we could talk two-way and three-way valves, but not in a controls aspect as much. So this would be another way that you could add redundancy to your system, would be to pipe in domestic cold water as a backup. And so you'd pull domestic cold water in from your, whatever your booster system or from the city supply, however your facility is set up, go through an RPZ style backflow preventer to get that separation to the non-potable side, and then be able to pipe that in line with the system using either a three-way valve or two-way valves on the supply, and then on the return. And it would be a single pass through, and on the return, instead of returning back into the loop, it would just go to drain. Okay, so you would single pass through the heat exchanger for the piece of equipment like the MRI, and then it would go to drain. And that would just give you enough to kind of keep it from overheating until you're able to fix your primary controls. But that would be a system that would trip on a high limit temperature in the secondary chill water loop, and then it would open up towards the domestic cold water, allow the water to flow through, and now you've got an additional layer of backup. So you would want to make sure that whatever drain that you pipe that to could handle the flow. It could be decent amount of flow coming through there, so you want to have that, and then also like kind of a flow restriction valve to be able to kind of regulate the flow through that heat exchanger, so it's not just wide open coming from your domestic supply. But another way to kind of add some additional redundancy to that system. The MRIs, obviously you want to protect the piece of equipment, but also want to be able to keep it operational as it's important to the function of the hospital for sure.
You would recommend something like this, it sounds like, for a renovation project, not just for new construction, but a retrofit or renovation project for someone that's interested in that secondary loop. So if you have an existing building and you pipe in the secondary loop, what are some of the operating considerations from a technician's expectations, or what can they expect to see as far as changes in their operation?
It's a good question. And, obviously if you're doing an expansion to an existing system, you're going to want to make sure that you've got the load capacity on your chill water system to be able to handle the additional load of the secondary loop. Assuming that's there, then you're going to want to have the additional points tied into your building automation to be able to monitor that secondary chill water. You want to see if you're out of range, being able to get those alarms. And then there would just be something that you would want to add to probably if you have, a PM, program, or kind of a routine where you're going through and checking equipment, making sure that it is performing like it should, for sure. But, making sure that you have those layers of redundancy in the actual equipment to do the heat transfer, and then even potentially the backup cold water would definitely be things to consider if you're doing an expansion or a new design.
Yeah, makes sense.
Yeah. Okay, last question. So you keep mentioning redundancy, which is like critical for hospitals, right? It's critical, but it's also something that's often value engineered out of projects, right?
Sure.
But some of these solutions sound like they're not really high cost. Like connecting in a domestic water and a three-way valve doesn't seem like a lot of cost to me. So like how do we just keep promoting these some of these lower cost options and have a focus on redundancy? Any thoughts there?
Sure. And if keep kind of going back to the example of the MRI, just because it seems to be the common one, but obviously this applies to other pieces of equipment. But I think kind of the question to ask back is, well, what happens if that piece of equipment goes down, and what is the impact? So how many MRIs would it take to pay for the additional pump that you want to, that we don't want to have on this job? And it's, these are not high flow rates. Typically they're not high head, so it's not the pumps themselves, the control valves, I'm not going to say it's not a lot of money, but when you look at the longer term and the impact that it could potentially have on the MRI, which is a very much of a larger capital expenditure, that's kind of where you would want to weigh, is that really a value engineering option to take out some of that redundancy?
Yeah, good point.
I like that. Awesome. Okay, Lindsay, anything else?
No, I mean, Tim, is there anything else we should know? I mean, we dove deep into secondary systems today. Did we forget anything that we should consider?
I don't think so. And, like I said, we talked a lot about MRIs, but again, anytime you're doing a secondary system, these types of considerations definitely apply, whether it's lab equipment, MRIs, anything like that. And so, if there's any questions on the design or anything, like an existing system or anything like that we could help with, we'd be happy to do that.
Awesome. Thank you.
Awesome.
Thank you for your time.
Absolutely. Thanks for having me.
Yeah.